This is the Chapter 2 review. I just want to let you know ahead of time it may end up being in more than one part depending on other obligations that I have. So we're going to hopefully get through as much as I can, as quick as I can. So the first thing is to talk about finding the derivative using the limit definition. The fact that it says limit definition is the clue that this is the long way to find the derivative. Because this says g of x, I'm going to write g prime of x. It is equal to the limit as delta x approaches 0 of this formula right here with x plus delta x plugged in minus the original formula. Oops, should be a minus. So there's x plus delta x plugged in, and now subtract the original. All over delta x. I know I said that you wouldn't have limits anymore. This is pretty much it. There's one other time where you'll have limits, but not to the extent that we had them in Chapter 1. Everything else at this point is just simplifying algebra. For example, if I take a binomial and it's squared, it's going to be the first times the first times the last, so that's your outer, and that's going to be an x times a delta x. The inner will be another x times delta x. And then this delta x squared will be the last. Every time you see delta x, it's its own individual variable. It's not delta times x. So keep that in mind. I'm going to distribute this while I'm here. And I'm going to distribute this negative as well. Clean up what I have. I have x squared. I have 2x delta x's. I have a delta x squared. I have minus 2x, minus 2 delta x. I have a plus 3, a minus x squared. I'm taking a lot of steps to do something that you might be able to do in 1 or 2 steps. I just want to show you exactly where everything is and how I got there. But at this point you can see the 3's cancel, you can see the 2x's cancel, and you can see the x squareds cancel. Everything in that last quantity should cancel because you should have a delta x in each of the remaining terms. If I factor out delta x, I'm left in the numerator with a 2x, a delta x, and a minus 2. Once I factor it out, now it can cancel with the bottom, because remember, it's the bottom that's the problem. That right there is 0. So once I get rid of it, then I can actually do some algebra, or not some algebra, but evaluate it where I wasn't able to before. I'm not going to actually show the plugging in of 0, just what would happen if this right here became 0. You would end up with 2x minus 2, which is the formula that generates the derivative, or it's the formula that generates the slope for that function at any given point. Sorry, that was a little off the screen. Meaning that the derivative is 2x minus 2. But the derivative is a formula. So if I wanted to find the slope at the point 1, positive 2, I think that's what you get. 1 minus 2 is negative 1 plus 3 is positive 2. The slope at the point 1, negative 2 would be the same thing as if I plugged in a 1 here. So 2 times 1 is 2, minus 2, it would be 0. Differentiability implies continuity, means if a function is able to be differentiated it must have been continuous. The opposite is not true, or not the opposite, but the converse is not true. Just because something's continuous does not mean that it's differentiable. For example, if it came to a point, a sharp point, you cannot take the derivative of a sharp point. Okay, determine the derivative. My son's starting to make some noise in the background, so I'll probably have to pause this pretty soon. Derivative of this function is 48x to the 5th minus 100x cubed plus 3x squared minus 15. The derivative of a constant is 0.